So we've got that equation, so how about we all enter that into our calculator so that we are all on the same page. So negative 259.65 plus 63.38 log of x. Before you start, before you graph, let's see what we already know. First of all, it's logarithmic, duh, right? It gives it away. We know that b, like this is a and this is b. This is x and this is y, always. Okay? So we know that t stands for the number of years. So that's your y variable, and a is the target value in dollars. So technically it's going to be dollar, like what you want, and years every time. We've determined that, right? This is y. Y is number of years, and then we put it there on the y spot, right? So the other one must be x. So that's one thing that you need to make sure you address that, you know that, especially with logarithmics, because they throw time in your y. Next, we know that b is positive, right? So what do we know about positive logarithms? We know that they never cross this axis here. So if there's a y-intercept, it can't be a log, right? Like, think about that too, right? So technically, we're expecting something like this. And in particular, because y is time, we don't care about this stretch of the curve. We only care about this part and then going further from there. Okay? So that's something important to understand, because you got to customize your window. I wish I could tell you there's this one button you can press and the graph will always be beautifully appearing, right? That's where you come in. Oh, and I also know, I don't think this one is very helpful, but A gives me a point. 1, negative 259.65. In this context, it's not very helpful. Like 1, negative 259 is way down here somewhere, right? So the curve will definitely go through there, but then we're interested in this part. So not really helpful, but it's good to know. Okay? So let's graph this. Horrible, it's not working. So I'm going to try zoom 6. Still not working. You can try zoom fit. I know that this is somewhere here, right? Somewhere to the right. So I'm going to try something. I'm going to go window. Let's go 1,000 this way. Still nothing. I'm getting impatient. I'm going to try 10,000. Oh, I saw something, right? You see something here. So now we know we have to go quite a ways that way. And think about, what is x here for us? X is money. Chances are we're going to have tens of thousands of dollars, hopefully, maybe millions, right? So it does make sense that it's a big number. So let's go, what should I go, 200,000? A bit overkill, but now I see it. I see some of it here. I'm going to, at the same time, increase my y, which is time. Let's go 100 years. Oh, and then it actually does a pretty good job. So that's how I chased my curve, okay? Knowing about the behavior of a logarithmic, okay? We're good? I don't know, I have to go mind reading. That's probably what I should do. That should be my master's in mind reading. Okay, the initial amount of money to be invested is $12,500. Oh, that's a good bit of information there. Okay. Is that possibly a point? I would argue yes. I would argue that they're saying that I have $12,500 when time is 0. That's actually giving me a point as well. So I should have maybe read a little bit more. Okay. All right. Make a graph of time required of money for amounts from 10,000 to 100,000. let's leave the graph for now, but I do want to graph this. I do want to graph this. So I'm actually going to make my grid already to account for it. So A, like this, and like this. So that's my spot for the graph. I can probably do the labeling already. This is amount invested in dollars, and this is time in years. Okay. How about we do B right here? Determine how long it would take to reach $25,000. Careful here, 25,000 time. It's asking me for that. So second trace 25,000, and I'll figure out what the time is. Second trace value 25,000. 19.09 years, no problem, because it's time. So that is my answer for B, which coincidentally is a point that I'm probably going to use for my graph. Okay, I'm going to use that. I'm going to have that there. How long would it take to reach 50,000? Let's just answer this. If we go 50,000, second trace 1, 50,000, it's 30.17. 38.17. Does that match? Does that match my key? Yeah, it does. Okay, good. We're good. So I do want you to always show the work and everything, but it's the same work as before. So I can use this point as well. Okay, got that. Determine how much money you could have in 25 years, right? So D is asking for, I'm going to do D here. D is asking how much money in 25 years, right? Because we know time is in our Y, so Y2 is equal to 25, second trace intersect, and I will get X being, X. So I'll let Y2 equal to 25, find the intersection, and that's 30,985.92. $92. Okay, so that's how much money we have. And now we've got a bunch of points that we can use. I'm going to add this to my mix here. 30,985.92 at 25. Okay, so all of these points are really good points that you can try. But logarithmic, because it comes up, logarithmic is going to come up somewhere here. It will never touch the y-axis, so it's going to just shoot up from the x-axis. So I would like to find the x-intercept. We were told it's 12,500. I'm just going to double check. Okay, so let's find that. Y2 is equal to 0. Second trace 5. Enter, enter, enter. It's almost. So it shouldn't. I didn't make this question. I borrowed it. So a critique that I can give is like, don't add this here, right? That confuses students, because if they find the x-intercept, like, how is it different? Why is it different? Like, what's going on here? So probably not a good idea to add that one. What I could have done is asked you, what was the initial amount invested, right? Without telling you, you find the x-intercept at time 0, you have this much invested. That would have been a good question, okay, in my opinion. So I hope that didn't throw you off too much. Sometimes when you model something, it's not exactly perfectly lined up. Okay, so let's graph this. What do we need? It says to include up to $100,000. We don't have $100,000 in our arsenal here, but we can quickly find that, right? I'm just going to do that. So second trace 1, I'm going to find the time it takes for 100,000. That's 57.25. No big deal, okay? So that means that I need to account for 100,000 here. So I'm going to use my ruler to help me out. Let's see here. 10,000, 20, 30, 40, 50, 60, 70, 80, 90, 100,000. So 2, 4, 5. This is my 50K mark. This is my 100,000 mark. That's good enough. You label, you're telling us what you're going up by. On my y-axis, I'm going to go up to 60. Like because 57 is the highest. I'm going to go to 60. It's just going to work. So I'm going to go 1, 2, 3, 4, 5, 6. 6 is at the very top here, and that's okay. Okay, so 20, 40, 60, way at the top there. I expect good graphs, so you know what? That's why they make erasers, right? Let's fix that up. 60 would get me to here. I'm going to extend it a little bit, make that my 60. This is time in years. Yes, hi. All right. And then you plot. We know the x-intercept is right here. 12,000. This is 10,000. This is 20, so this is 15,000. So 12,000 is somewhere, 12,500 is somewhere in there. I'm going to use the 50,000 next. 50,000 is 38, which is right about there. 100,000, we're at 57, which is right about there. So don't be scared of graphing. You may use any point that you can find. You have your calculator to help you out. I go from here, but just make sure it's not a straight line. We're expecting it to kind of curve away like this. Okay. Expecting it to curve away. And just to make sure, if you're interested in full marks, you just make sure you add the actual equation, page 40, and then there's your graph. We do not need the asymptote. We don't need you to graph it. We just need to make sure you don't touch it. Okay, so whatever you do, don't touch. Okay. And this one you might think like, why would I do that? I would never even come close to it. But remember, guys, there are instances where you're going to come from up here towards the x-axis, so the action is going to stop at the x-axis. That is where you have to be careful not to touch the y-axis no matter what you do. Okay, you do not make contact with it because then you lose marks. We're good, Julian? I probably overdid.